Hi guys, in this video we are going to discuss factoring polynomials. Okay, lesson 3, factoring difference of two cubes. Okay guys, I want to emphasize that this is part 1 of lesson 3. Okay, so let us just focus first on factoring the difference of two cubes. Okay, our objective, after watching this video, you will be able to factor completely and accurately difference of two cubes. Okay, in this lesson, we need to recall our knowledge about perfect cube numbers. So here are some examples of perfect cube numbers from 1 to 10. So these are the numbers, and these are the cubes, and these are the exponential form. Okay, so guys, when we see cube, the numbers are being multiplied by itself 3 times, and the result are what we call perfect cube numbers. Okay, and these numbers also can be expressed as exponential form. So this is the exponential form. So meaning to say, the base 1 is being multiplied 3 times, base 2 is being multiplied 3 times, and so on until 10. Alright? Now, what is perfect cubes? Perfect cubes are numbers or expressions that can be expressed to the power of 3. Now, expressing to the power of 3, so let us take this expression here. 27x raised to 6, y raised to 12. Okay, let us work step by step or individually. Let us first work with the numerical coefficient. So 27 can be expressed into expanded form. 3 times 3 times 3, multiplying 3 by itself 3 times. So this can be expressed also into exponential form, 3 raised to 3. Alright, meaning the base 3 is being multiplied by itself 3 times. Then for x raised to 6, that is quantity x raised to 2 raised to 3. So meaning to say, the base x squared is being multiplied 3 times by itself. Then for y raised to 12 can be expressed as quantity y raised to 4 raised to 3. So meaning to say that the base y raised to 4 is being multiplied by itself 3 times. Okay, so we have the 3 bases. So putting up together, so this is now the exponential form with the power of 3 in the given expression. Alright. Okay, so we're going to determine the product of this expression, binomial multiplied by a trinomial. Of course, we need to apply the concept of distributive property of multiplication. So meaning to say that each term of the binomial should be multiplied to every term in the trinomial. Okay, let us first multiply x times x squared, that is x cubed. Then x times positive 2x, that is 2x squared. Then x times positive 4, that is positive 4x. Then we will do the same in the next term of the binomial. So negative 2 times x squared, that is a negative 2x squared. Then negative 2 times positive 2x, that is negative 4x. Then negative 2 times positive 4, that is negative 8. And then, after doing so, we will now combine similar terms. Alright? So in this case, we have the similar terms. We have also this one. So since the similar terms having the same numerical coefficient, then opposite sign, so this will become 0. So what will remain in this expression now is x cubed minus 8. Okay, this is what we call difference of two cubes. Why difference of two cubes? It's because the operation here is subtraction and both terms are perfect cube numbers. Alright? Now, in this lesson, we are going to do the reverse process or working backward in order to go back with the factors. And to do that, we need to apply the formula. Okay, and I want you to remember this formula. Alright, so working backward or reversing the process. Okay, let us take the formula itself. First thing to do is draw two blank parentheses. with the operation here in the binomial subtraction. In the trinomial, we have two additions. So the operations here are constant, do not change. Okay. Now, and to obtain the binomial factor and the trinomial factor, there are steps to follow. Okay. So steps in obtaining the binomial and trinomial factor. Number 1, to get the binomial factor, subtract the base of the first term by the base of the second term. So we need to subtract the base of the first term, which is a, by the base of the second term, which is b. So that is a minus b. So this is now the binomial factor. And how to obtain the trinomial factor? Okay, we will follow the steps. First, we have square the first term of the binomial factor. So this is the binomial factor and this is the first term. So we're going to square this one, meaning multiplying a by itself, the result is a squared. This is now the first term of the trinomial. Then obtaining the second term of the trinomial factor, okay, multiply the terms of the binomial factor. So we need to multiply these two. That means a times b, that is ab. Then obtaining the last term of the trinomial factor, we need to square the second term of the binomial factor. Okay, squaring this second term, so negative b will be multiplied by itself, and that is positive b squared. So this is now the complete factored form of this expression. Okay, working backward or reversing the process. So we are going to apply this method in the succeeding examples. Okay, so let us take this example number 1. Factor y cubed minus 27. Right? So before we could apply the formula, we need to express 27 into exponential form by the power of 3. And that is 3 raised to 3. Then applying the formula, draw two blank parentheses with its operations. Then obtain first the binomial factor following the steps. Of course, to get the binomial factor, subtract the base of the first term by the base of the second term. So subtract this one, so y minus 3. Okay, so this is now the binomial factor. Then obtaining the trinomial factor, follow the steps. Square the first term of the binomial factor. So we need to multiply this one by itself in order to obtain the first term of the trinomial. So that is y squared. Then obtaining the second term, multiply the terms of the binomial factor. So we need to multiply these two. That is y times 3 or 3 times y. That is 3y. Then obtaining the last term of the binomial factor, a trinomial factor, square the second term of the binomial factor. So we are going to multiply this one by itself. So negative 3 times negative 3, that is positive 9. So this is now the complete factored form of this given expression. Okay, example number 2. Factor 8x cubed minus 64. Alright, so you have noticed guys that both terms can be expressed into exponential form by the power of 3 directly. But take note also that both terms have something in common. So we have what we call the greatest common monomial factor. So let us apply this one first. Okay, so this is our first factor and this is the other factor. How to get this? So apply your previous knowledge in factoring polynomials by the GCMF. Okay, just divide each term by the GCMF and you will obtain the other factor. Alright, and then so this is our first solution. Then let's proceed to the second solution. So since the other factor is the difference of two cubes, so we can now apply the formula that we need to express this one first into exponential form by the power of 3, and that is 2 raised to 3. Alright, then draw two blank parentheses with its operation. Subtraction in the binomial, then two additions in the trinomial, then follow the steps. Okay, this time I will not I'm not going to show to you all the steps. I want you to memorize all of those. So to get the binomial factor, all you need to do is subtract the base of the first term by the base of the second term, that is x minus 2. And how to obtain the trinomial factor? First, determine the first term here. Just multiply the first term of the binomial by itself, and that is x squared. Then, obtaining the second term of the trinomial factor, just multiply these two terms in the binomial factor. So, x times 2 or 2 times x, that is 2x. How to obtain the last term of the trinomial factor? Of course, we're going to multiply the second term of the binomial by itself. So, negative 2 times negative 2, that is positive 4. Alright? Then, putting all factors together, we have 8. Then, the binomial factor. Then, we have the trinomial factor. So, this is now the complete factored form of this given expression. Okay? Now, example number 3. Factor 27m raised to 4 minus 8mn raised to 6. So, still we have two solutions. Both terms have what we call the greatest common monomial factor, and that is m. So, this is our first solution. So, the GCMF. Then, the other factor. Again, how to get this? Just divide its term by the GCMF. Okay? So, this is now our first solution. Now, next solution, before we can apply the formula, we need to convert its term first into exponential form by the power of 3. So, for 27m cubed, the exponential form by the power of 3, that is quantity 3m raised to 3, meaning 3m is being multiplied by itself 3 times. Alright? So, 3 times 3 times 3, that is 27. M times m times m, that is m cubed. That is also the same with 8n raised to 6. So, quantity 2n raised to 2 raised to 3. So, meaning to say, this base is being multiplied by itself 3 times. So, 2 times 2 times 2, that is 8. Then n squared times n squared times n squared, that is n raised to 6. Alright? So, we can now apply this formula to draw two blank parentheses. Of course, the same operation. Alright? Then, obtain first the binomial factor. How to get this? Again, subtract the base of the first term by the base of the second term. So, this is the base of the first term, 3m, minus the base of the second term, 2n squared. Alright. So, this is now the binomial factor. And how to obtain the trinomial factor? Of course, we need to determine first the first term. So, how to obtain this? Multiply the first term of the binomial by itself. So, 3 times 3, 9. Then m times m, m squared. So, 9m squared. So, this is the result after multiplying this one by itself. And then, how to obtain the second term? Okay, multiply these two. So, 3 times 2, that is 6. Then, m times n squared, that is mn squared. Okay, so this is now the result, 6mn squared after multiplying these two. Then, how to obtain the last term? Okay, multiply the second term of the binomial factor by itself. So, negative 2n squared times negative 2n squared, that is positive 4n raised to 4. Alright? Then, putting all factors together, we have m, the GCMF, then the binomial factor, and the trinomial factor. Okay? So, this is now the complete factored form of this given expression. Alright? So, thank you for spending your time in watching this video. Guys, I hope you learned something. So, see me in the next video. Happy learning!